This is an example of a parallel circuit, finding the equivalent resistance and analyzing the circuit. So for parallel circuits or parallel combinations of resistors, the equivalent resistance is equal to 1 over the first resistor plus 1 over the second resistor plus any more of those terms that you need for the number of resistors that you have. Let's work an example so you can see how this works. So I'm going to have 3 resistors in parallel, and I'm going to put this other one up here. You see that this one is also in parallel because there's a branch here, and then they come back together there. So sometimes it can look a little bit different, but they're still parallel. And here's R1, R2, and R3, and a 6-volt battery. And let's draw our chart. So we have a place, organized way to record all of our values, and a row for the total values. Okay, and the resistor values I'm going to put here. This is 5 ohms, 10 ohms, and 17 ohms. So let's fill those in our chart. 5 ohms, 10 ohms, and 17 ohms. So these 3 resistors are all in parallel. So let's find the equivalent resistance first. Should also put 6 volts there. Okay, so we have 1 over the equivalent resistance equals 1 over 5 plus 1 over 10 plus 1 over 17, applying this equation, which you should write the equation before you substitute the numbers. I'm just going to show you a quick shortcut for how to solve these kinds of problems on your calculator. You may have a button that is the inverse button, so it could say x to the negative 1, or it could say 1 over x. So look for a button on your calculator that either says this or that says this. Both of those I would call the reciprocal button. This is 1 over 5. So if you put in 5 and then hit your x to the negative 1 button, it will calculate 1 over that. So that is this. 1/5 is 0.2. And then I want to add my next value, 10. But I don't want to add 10, I want to add 1 over 10. So if you do 10 to the negative 1, that's 1 over 10. Or if you have this button, put in your 10 and then hit the 1 over button and it will calculate 1 over that. And then plus 17, 1 over, and that gives me 0.3588. So 1 over the equivalent resistance equals 0.3588. Now that means that 1 over the equivalent resistance is 0.3588, and if I multiply both sides by the equivalent resistance, we get that 1 equals 0.3588 times the equivalent resistance. Divide both sides by 0.3588, and we find that the equivalent resistance is 1 over this number. So it's the reciprocal of the number that you get here, which means that I just need the reciprocal now of that value. So I'm going to say I want to take my previous value, find the reciprocal, and it is 2.8. So that's just a little shortcut way to use this equation on your calculator. So 2.8 ohms is my total resistance for the circuit. Now what we want to do is find the rest of the values for the circuit. We want to analyze the circuit and find the total flow, and then find the flow rate and the pressure difference for each resistor in the circuit. So the first thing we're going to be able to find, looking at our chart here, we don't know any of these values, but we have 2 values for the total circuit, the circuit as a whole. So let's find the total flow rate. So pressure difference equals flow rate times resistance. 6 volts equals flow rate times resistance. And the total flow rate is going to come out to be 2.14 amps. Think about now where this is happening in your circuit. It's always going to be the total flow rate in that branch from the battery before there's any splits. The very first split happens here. I'm going to call that A. And your total flow rate is also going to be happening out here. So this is I total, and this is also I total. At this point, you're going to have some branching. The next thing we could find, let's see. Do we know anything about the currents? Well, the current's going to split up, so none of these values will be the same as this one. Will any of these values be the same as this one? Well, let's think about our color coding, and I'm going to color code this circuit quickly. I really recommend still color coding. It can really help you see some things you might not see otherwise. Well, it looks like the pressure difference across R1 is red to blue. Across R2 it's also red to blue, and across R3 it's also red to blue, which is just the total pressure difference. So it looks like we know all of these are 6 volts. And now we can use Ohm's law to calculate these other values. So we're assuming here that these resistors are ohmic and that they have a constant value at all the different pressure difference values. So let's find the flow rate in resistor 1. So 6 volts is the pressure difference. We don't know the flow rate, but we do know the value of the resistor. And so we can find that the flow rate in the first resistor is 1.2 amps. Okay, so that means that we start out with 2.14 amps going this way. And in this branch, 1.2 amps is flowing. Which means the rest of it's going here, and then it's going to split up again. So now we need to find out how much goes into resistor 2. So now applying this to resistor 2, we have 6 volts equals I2 times 10 ohms. And that means that the flow rate is 0.6 amps in resistor 2. And at this point, you could apply this relationship again to resistor 3 to find the current. Let's look at another way. You can also find it using these values, using just the other currents at different places in the circuit. And that's because the total flow rate has to equal the flow rate in each of those branches. So if the total flow rate is 2.14 amps, and the flow rate in resistor 1 is 1.2 amps, and it's 0.6 amps in the next one, then we can find out what it is in the third one. So 2.14 minus 1.2 minus 0.6 is 0.34. And so that is our flow rate in the third branch. Okay? So the flow rate in each of these branches has to add up to the total flow rate.